So the next poster is reusable ATE interface, making the most out of a Uni-Board, mDIB. It is presented by Senthilkumar, Dhamodharan. Go ahead.
Hi all. Today we intend to present our work on reusable ATE interface, and the authors of this poster are Senthil, Mohan and Prabhakar. On behalf of our company, Caliber Interconnect Solutions, we thank TestConX for the opportunity. To start with, let's discuss the impetus behind our proposal, subsequently the implementation, and so on. We all know that for many mid-tier and low-tier IP companies, investing on ATE hardware interface may become untenable in case of multiple IP designs. So, any approach which can reduce this repetitive hardware needs for the similar devices will be of great help. This not only bodes well for the customers, but also bolsters the sustainability goals of our industry. With reusable ATE interface, we set out to minimize the impact on financial and ecological bottom line for our customers with 4 points approach. Motherboard and daughter card approach. Maximum utilization of available tester resources. Motherboard designed for maximum instrument specification and minimal modifications made in daughter board design. Finally, universal socket technique. In this specific case, we have implemented reusable hardware approach on Advantest V93K platform for a series of products. During the pre-design stage, we have considered the following aspects for better reusability: resource planning, common circuits, interface techniques, layout design, signal and power integrity simulation. We need to maximize the resource utilization through motherboard. This is an example where we have shown how it's being done for the sample instruments in Advantest V93K such as PS1600, AV-I64 and DPS128. In Smart Switching Solution, we incorporate the common circuits of similar family devices and default tester circuits such as EEPROM circuits, MUX circuits and relay switching circuits. Protection circuits are used to guard other instruments from high voltage cards and have been implemented on motherboard itself. Operating and compliance ranges of the instruments for Advantest 93K are given here. This is the sample protection circuit for the digital instrument in 93K. We have two interface techniques, connector interface and pogo tower interface. We need to consider the following parameters before going for connector selections, that are low loss, voltage rating, current rating, frequency, high matting cycles. Pogo tower interface gives better lifespan, but it's quite expensive. In connector mating, we have designed in such a way that each connector assignment constitutes of combined resource usage such as digital, power, G&D. This approach will add modularity for daughter card design. This is how motherboard and daughter card are connected through high-speed connectors for better signal performance. Layout design. These are the basic things we need to consider while designing motherboard and daughter card. SI/PI. We have relied on SI simulation for better signal strength and on PI simulation to find voltage drop, power ripple, etc. Universal socket. This is one of the unique approaches that allows us to support initial bring-up of any ICs using just the motherboard with the aid of universal socket. You don't need to invest on separate daughter card. Applications. This approach will be suitable for below applications like test chip bring-up, similar package type validation, IP development, low volume product screening. Trade-off. The pros and cons of this approach are as follows. Cost saving is up to 75% in hardware development. Hardware design and lead time will be reduced. Repeated circuits can be avoided in daughter board for similar family chips. For high precision products, there are certain challenges. Also, adapting this approach in production may have some bottlenecks. To summarize, the motherboard and daughter card concept will help in optimizing design, effort, cost, and most valuable of all, time that can be used effectively in accelerating the bring up of devices to reach the market on time. Thank you.
I had a question for Senthil and the team. So one of the challenges that are faced when we do this kind of testing, as you mentioned, is the connectivity of those connectors, right? If I'm going to go develop this for a non-production solution initially at a low volume, like you suggested, and when we migrate it to a production solution, how do we then sit and correlate those? That have you thought about that as a challenge? Because in a production environment, your connectors and stuff really don't have a lifetime to sustain long-term production at high volume. So how do you correlate the two, and how do you bridge that gap?
So for now, like we developed this particular board in-house for the engineering bring-up, but it's a good question actually. So we are yet to do a correlation between the same kind of case study for an engineering bring-up versus the production setup. But then, so to answer you in short, there there are some kind of like made cycle. Lifetime made cycle for each connector specifically. So that can give us some rough idea on that.
And also to increase the lifetime, we can opt for a POGO cover-based solution, but it can be costly, can be expensive.
That is right.
Okay. So thank you for that answer, and especially being in India, stay safe, please.
I want to once again thank our sponsors who have made this event possible, our premier sponsor, Kohu, our emeritus sponsor, JonsTech, our honored sponsors, ISC, iWind, and TSC, our distinguished sponsors, Backer Hotwatt, Innovative Circuits Engineering, JMT, Nidec SVTCL, R&D Altanova, and UI Green, and our exhibitor sponsors, ELES, MJC, Phoenix Test Arrays, and Smith's Interconnect. So when you have a chance, please thank these companies for sponsoring, which has made this event possible and has made it available free of charge. And once again, I would like to thank Kohu, our premier sponsor, the market leader in test interface solutions for the most challenging applications, and ISC, the global #1 total test solution provider. So we thank them both for their leadership. And once again, I thank everybody for attending, and we look forward to seeing you again tomorrow at 7 a.m. Pacific. Thank you.